Hello friends, welcome to a new session of data science. In this video, we are going to see the recommender systems. Recommendation system is the way by which we recommend something based on the previous data. So there are multiple ways by which the recommendations are possible. So we are going to use this in this particular video using Python programming. It's recommended that you must be knowing Python, pandas and natural language processing. Let's start with so you might have seen Netflix is having suggestions of movies based on the movies that you have already watched, or an e-commerce website that displays an option frequently bought together. Okay, they may look relatively simple options, but behind the scenes the complex statistical algorithm executes in order to predict these recommendations. Such systems are called as the recommender systems, recommendation systems, or recommendation engines. A recommender system is one of the most famous applications of data science and the machine learning. It employs a statistical algorithm that seeks to predict users' ratings for a particular entity based on similarity between the entities or the similarity between the users that previously rated those entities. The intuition is that similar type of users are likely to have similar ratings for the set of entities. That's what similarity measures are used, and based on that the recommendations are given to a new design. So that in that way you are going to make use of it. So it's somewhat similar to the association rule mining, but this is a data mining algorithm. Here we are not going to do mine anything. We are going to find the similarity measures, and based on that a new recommendations, a set of recommendations will be given to the new user. Now, where do we use the recommendation systems? Currently, many of big companies are coming out there for recommendation systems in a way or another. You can find them anywhere from Amazon in product recommendations, or YouTube in video recommendations, or Facebook friends recommendation. These are the applications of recommender systems. The ability to recommend relevant product or services to users can be a huge boost for a company, which is why it's so common to find this technique employed in so many different sites. There are many ways by which the recommendation systems are used. Out of it, very commonly used, very popularly used algorithms are content-based filtering and the collaborative filtering. These two commonly used algorithms are used for recommendations. They are working as the recommendation engines. We'll try to identify how these algorithms will work first, and then we are going to make use of these algorithms in the practical implications of it. Okay, so let's start with the first. What do you mean by content based filtering? In content based filtering, the similarity between different products is calculated on the basis of attributes of the product. Okay, the similarity is calculated on the basis of attributes of the product. For instance, the content based movie recommendation system, similarity between the movies is calculated on the basis of genres, actors of the movie and director of the movie, like this. So this is a similarity identified, and based on that the recommendation will be given. So this is how an example that we can consider is used on YouTube. So YouTube is also performing the same operation. The genre which you are watching currently, the type of actors we are watching currently in the movie, or director of the movie is similar kind. This is what similarity are there that movies are having, and based on that the recommendation will be given to you. Okay, when you're watching a movie on YouTube, you can see that on the right hand side bar you just can see other videos. We are having similar kind of things that the current video is also having. So content are same, and based on this similarity contains the recommendation system behaves, works. And the second is collaborative filtering. Collaborative filtering leverages on the power of crowd. Okay, the intuition is that collaborative filtering is that if a user likes product X and Y, and if another user B likes product X, there is a fair bit chance that he will like the product Y as well. Yes, means they are of same kinds. So that's what the consideration is done over here in this algorithm. Take an example of movie recommendation system. Suppose a huge number of users have assigned the same rating to movies X and Y. A new user come who has assigned the same rating to movie X but hasn't watched movie Y. So collaborative filtering will recommend him the movie Y. This is what the collaborative filtering is. It's called power of crowd. Power of crowd is the basic function, basic core behind the collaborative filtering, which is used for recommendation systems here in this. Now let's start with the simple example here. It's a very commonly used example for movies recommendations. Let's develop a algorithm for a movies recommendation systems. We'll develop a very simple movie recommender system that uses the correlation between the ratings assigned to different movies in order to find the similarity between the movies. Okay, so let's use the data set. The data set that we are going to use for this problem is movie lens. It's very popularly used data set. Okay, so download data set, we have to go to this particular link which are mentioned below. See, grouplens.org, data sets, movie lens latest. Okay, the data set, download ml latest small zip, because see, many different data sets are available over there. Out of it, we are going to use the smallest data sets available. Just can check it out. This is the website of grouplens, and from the group lens we are going to download this movie lens data set. Okay, this is 265 MB, very large data set available, and here this is 1 MB data set. Okay, so once you unzip the downloaded files, you can find the links movies.csv, rating.csv, tags.csv files along with the readme document. And in this article we are going to make use of movies.csv and the ratings.csv files. Okay, so I'll just open this particular file which I have downloaded here. Okay, this one. So this is movies.csv file which will contain information about the movies, and one more is there. Along with it, we are going to have the ratings.csv file also. So in ratings.csv file, we are going to have the ratings of the respective movies. So based on the users, these ratings are provided here. So let's check it out. So the data set given to us is very big. Okay, let's open this and just check how and what kind of movies and their information is present inside it, and based on that we are going to make use of this particular data in our program, and we'll provide the recommendations to the users of based on the movie. So let's see this. Take this one. Okay, so this is movies.csv where movie ID is given and the name of the movies along with this the year of release is also mentioned over there. See this one. Okay, so lot many movies, the information is maintained inside it. Check this out. Okay, so this is movies information, ID and its name, and the ratings. It contains the user ID, user who has given the rating to this particular movie, then movie ID of the movie, and the rating which we are provided, and the timestamp means the time when the user has given this rating to it. Okay, so though the thing common in these two different data set is the movie ID. Okay, so this movie the rating is provided, and based on that, so I will provide recommendations to the users. Okay, so let's go for this. Let's check it out how to do this one. So we are going to make use of the mechanism of collaborative filtering, by which we will work on a power of crowd. And power of crowd, okay, will suggest the movies if the user has not watched the movie. So the recommendation will be given based on the previously rated users. Okay, so let's import the numpy first, import the pandas, then ratings.csv, and then we'll see what the rating.csv file is containing, the head of it, what 5 entries. See, this is what ratings file is present. As we have seen, we have opened that particular file already, user ID, movie ID, rating, timestamp. Then let's read the movies.csv file. This is movies.csv file. They are the top 5 movies present in this particular file there. Now parallelly I'll not work on these movies or both of these files. I'll combine these files together with the help of a merge function of pandas. So let's see this one. The first what we have is ratings data and movies names. So we'll combine pd.merge, okay, ratings data and movie names on what's a common thing that we are having on movie ID. So where the movie ID is common, let's merge this two data frames together, and we'll have a movie data created. So let's see. Yes, this is how it's combined. So the movie ID is common there. So this is what movie ID is, and the users, okay, the users are different here. Movie ID is common. This is Toy Story 1995, and user are different. Users have given the ratings 4, 4, 4.5, 2.5, 4.5, something like this. Okay, and these are the genres of that particular movie is mentioned over here. Fine. Now let's do some statistical work on that. Maybe they are useful for us to understand how exactly we'll work on this particular system by using collaborative filtering algorithms there. So first of all, first 5 movies along with their average ratings. What I have done here, data frames name movies data dot group by, title, okay, group by title. On that title we are going to make ratings mean for if title is common, like for example Toy Story 1995. So title is common, so mean of all the ratings will be given and that will be printed. So top 5 I am showing over here. Let's see this. The movie is 71. Total mean rating is 4, Hellboy 4.5, Round Midnight 3.5, like. So we combine all of their ratings together and then new data frame is formed over here. Let's sort that value. Sort the ratings in descending order of their average rating. So by using same method, I just applied sort values function here by using descending order, because ascending I made it false here, and first 5 entries that will be shown. So these are the top popular movies whose ratings are 5. It's 5 out of 5. So you can check it out. Carlson Returns 5.0, Winter in the Protoscov Hensi Vashino. Okay, what's that? My Love 5.0. Okay, like all this. So these are the top movies whose ratings are mentioned and how many users have rated. This is what I have done. I am finding the mean of all the ratings. Now here the total number of ratings, here I am using a count method. So count will find total number of users who has given rating to this particular movie. Now check this. So which movies are getting maximum number of ratings? Maybe see, the thing is that if I consider this movie My Love, which is released in 2006, its rating is 5.0, but it may be possible that only one user has rated this movie. So based on only one user's rating, a recommendation system will not be considered trustable. So what will apply? We'll check how many users have given the ratings, and I will have a threshold value, for example above 100 users or above 200 users or 500 users. If they are given the ratings, then only consider that movie in the recommendations, like. Okay, so for that purpose I'm using a count method. How many users have given the ratings, and that's what we can see. In Forrest Gump it's got highest number of ratings, highest number of users we have rated for that, 329. Okay, and then Shawshank Redemptions and then Pulp Fiction, like all. Okay, so this is how count can be calculated. Now we'll create a ratings mean count data frame and first add the average ratings to each movie to this data frame. So what I have done, average mean count data frame, movie group by title and ratings mean. Okay, it's fine. And then after add the number of rating for a movie to the ratings mean count data frame. So we'll add it there. Let's see what I have done here. The operation that we have done previously, I just combined them together. How? See, so rating of the movie and how many users have rated to this particular movie. So you can check it out. So 4.0 rating, 71 is a movie name. Okay, 4.0 and ratings count is 1. So only one user has rated. Okay, if only one user has rated there, it will be not trustable to recommend this kind of movies to the new user. So that's why the count is very important over here. Though the rating is high, rating is low, count is very important factor to consider. So let's see how these counts and how these ratings are actually done there. So first of all, I'll plot a histogram for the number of ratings presented by the ratings count. So here I'm using Matplotlib Seaborn. So for Seaborn, I'm setting a style, dark style I'm using here. Then figures effect ratio is 8/6. Okay. Then RC from age color, okay, ages are given true. And here I'll be making ratings mean count, rating count dot histogram. Okay. I'm calculating, showing over here. Let's check it out. So this will be the histogram of it. Let's check. Okay, see, these are the ratings counts, okay, which are provided over here. How many ratings are given? So almost from 0 to 50 or maximum 100. Okay, so more than that, very less number of movies are present there. Okay. Now we'll plot the histogram for average ratings now. Now for average ratings, so we'll be using 8/6, and here average ratings mean count rating is provided. So well distributed actually, the ratings from 0 to 5. Okay, so maximum number of ratings are at 4 almost. You can check it out. Then 3 to 4 maximum number of ratings are present. Very less number of users having 0 to 1 or 5 also. Very less number of are present. That's what we can find the analysis of this particular data with the help of the histograms. Now one more figure will plot the average rating against the number of ratings, average ratings against the number of ratings. Okay, so here I'm using a join plot where x is ratings, y is the ratings count, and data is rating mean count. So that's how you can find the, yes, check this, these are the ratings count and these are actual ratings. See the number of count which are provided, see, and ratings actually provided over here. So you just can check it out. It's very huge amount of the data is present over here. If you go to above 300, the movies which are given rating above 300, they are almost having rating 4, greater than 4 to 4.5 almost. Say this one, that we can find by using this joint plot. Okay, so this is how the joint plot can be calculated. Now, very important factor before actually creating a recommendation systems, we are going to make a matrix of movies titles and corresponding user ratings. So for this purpose, I'll be using the pivot table function here. So from movies data, I'm using pivot table function where the index I'm providing user ID. So user ID will start from 1 to 3 onwards, and column will be title and values will be ratings, which I'm providing inside. Column is title, values of ratings, and this is how it's possible to create this particular table. Okay, now check this out. What I've done, this is your title, user ID, which is the index which are providing user ID to index, and these are the names of the movies and whether the user has given the rating to particular movie or not. For example, user number 1 has not given a rating to this movie, or user number 4 has not given a rating to this movie. That's why it is showing nan, not a number. This is how we expanded the data, just like one hot encoding. Okay, just consider that every movie is different column and every user is a different row. Whether the user has given rating to the movie or not, we are identified by using this particular structure. So here in this snapshot, I'm having only user number 1 has given rating to this movie, 3 Amigos. See, and remaining other 1, 2, 3, 4, 5, they are not rated anywhere. So completely the number of rows will be the number of users and number of columns are the number of movies. So you can check it, 9719 number of columns. With that number of movies are present over here. Okay, and if you just check the dimensions of this, okay, this is, can use the users ratings and check the dimensions. So 610 users are there and 9719 movies are present there. Okay, same operation we have done in association rule mining also to convert that data in our represented format. Now this is how the conversion is done. What we are focusing on, the number of users, the users and the movies. That's what we converted. User IDs on rows and movies is on columns. Now we are going to create the recommendation systems. Now I want to find the ratings of Toy Story 1995. The movie is this, Toy Story 1995. So let's use this movie user ratings, and this is the column which I'm providing, and then we'll find it. Check it out. All the ratings provided to Toy Story. So user number 1 has given rating 4.0, user number 5 has given 4.0. So all of their ratings can be seen by this particular method, Toy Story ratings. Okay, because this Toy Story I am given this name. You just can change this name of the column, name of the movie, and that movie's rating can be shown here by this way. Now let's try all the movies that are similar to Toy Stories. All the movies related to Toy Stories. See how to do this now. So I'm creating these movies like Toy Story. So from these ratings, I'm using a function corr with. That is what we call as correlation with. Now correlation with, so what's the rating which is provided to Toy Story? Say same ratings I'm providing as parameter here. So user movie ratings and their correlation I'm going to find. Okay, so this by using correlation with function will find the correlation with the Toy Stories ratings here. Okay, then I'm going to create data frame. So this is what we call movies like Toy Story. I'll identify that. Okay, and the column will be correlation. So that will be correlation factor. So how they are correlated means how many users ratings are matching with the Toy Story other movies ratings are matching with the Toy Story 1995. That's where we are going to calculate. This factor will be there, and that factor we call as a correlation factor. Okay, and if there is any NANR present, NAN, so I'm using drop NA method to clean that values in place true, and then let's see this one. Now just can check it out. Relation with the Toy Story, how many are actually matching? Now just check it out. Now that's what I calculated. This is the correlation factor. Okay, the same rating that is provided as that of Toy Story, that we are going to make use of. Title, and these are the correlations. So you just can check it out. Burbs, the Burbs, this movie is correlated with the Toy Story 1995 with 24%. This is 100%. 10 cent pistol, 100%. Means the ratings of this movie and ratings of the Toy Story 1995 is almost same. That's what the correlation with is showing. Means how they are actually same or they are completely different. These factors are identified with the help of the function corr with, that is correlation with, and that correlation is shown in the form of the data frame presented in front of you here. Okay, done. Now sort the movies in descending order to correlation with highly correlated movies. So we got that correlation factor will show you which movie is highly correlated with your original movie. That's why correlation factor is very important. So we are going to do, we are going to sort the movies in descending order of correlation to see highly correlated movies at the top. Okay, so how to do this one? This is what correlations that this data frame we got. Sort the values according to correlation, ascending false, and top 10 entries will be shown over here. Check it out. Now these are the movies which are correlated with Toy Stories but with factor 100%. So the rating of Toy Story and rating of these movies are almost exactly matching. Top 10 are all 100%. All of they are 100%. They are matching. This is how the correlations will be shown, and we are going to make use of it in descending order. So highest correlation is given on top, and then lower, 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 and last one the lowest correlation factors will be shown there. Now I am not worrying about the correlations are given there, because we have already talked on that. If only single user has given the rating, then also it will be matching 100%. I need to focus on the count. So let's define one count, that if this number of users are given rating, then only consider that. So I need to add the count class, so count column also to this particular data frame. So retrieve only those correlated movies that have at least more than 50 ratings. To do so, we'll add the ratings count column from the ratings mean count data frame to our correlation Toy Story data frame. So this is called correlation Toy Story data frame. Join, what you are going to join? So I'm going to join this ratings mean count rating count column to it. Okay, so that ratings column is added, and let's see this one now. Now correlation and ratings count both are present here. Okay, if you see, this is 10 cent pistol. Okay, 10 cent pistol, it's containing 100% correlation, but the thing is that only 2 ratings are there. So both of these ratings are matching with the Toy Stories. If they are matching, so that's why it's giving correlation 100%. Okay, only 2 are there. So 2 is not a significant count that we are going to consider. So what we need to focus on? We have to focus on both. We have to focus on correlation factor also and the ratings count also. So what I consider here, at least 50 ratings should be present. If 50 ratings are there, then only consider its correlation there. Okay, so how to do this is the last one. Filter the movies related to Toy Story that have more than 50 ratings. So what I have done in correlation Toy Story, its rating count should be greater than 50. Okay, sort them according to correlation in ascending order, and check top 5 movies which I recommend on the Toy Story. So check it out, Toy Story 1995. So same name, it's 100%. Total 215 ratings are there, which are Toy Stories actually containing, match with Toy Story itself. Okay, then second recommendation is 69% correlation with Toy Story 2, released in 1999. The ratings count are 97. Okay, then Arachnophobia, that's 65% matching correlation, 53 ratings are there. Incredibles, matching 64% correlations, ratings count is 125. So 125 user rated and correlations are 64%. That's why I can recommend it. Finding Nemo, 2003 release. It is 61% almost matching. 141 counts are present there. So these are the top 5 movies which I can recommend when you are watching Toy Story. So Toy Story itself is the part of it. So let's take top 10. See, top 10 movies which are having correlation descending order, and the ratings count is above 50%. So if you are watching Toy Story 1995, so you can watch these 10 movies also along with it based on the recommendation given by the users. So users recommendations and the correlation factors they have identified, based on that we are given the recommendation to the users. You just can check it. For example, I want to find the recommendation for this movie Aladdin. So let's go for Aladdin. So I'll just make a small change here. I'll change the name of the movie Aladdin. Okay, so let's give it Aladdin and execute the same lines. I'm just changing the name of the movie, nothing more than that. Okay, yes. Now see, these are the movies which I can now recommend when you watch Aladdin. So Aladdin, 183 counts are there, and along with that Wallace and Gromit, The Wrong Trousers, just 73% correlation, and 56 ratings are given. Sting, okay, it's 71%. Then 12 Angry Men, just 57 ratings and 71% matching, like this. In this way, your recommendation system based on the collaborative filtering will work. And anywhere, so this is all example I've given for the movies data set only, but we can make use of any other data set also which is having the similarity kind of things. In this way, collaborative filtering with the power of crowd, the power of users who are rated for the particular movie is used here to provide the recommendations. Any n number of such recommendations are possible by using this. I just check it out how many actual ratings are possible and present here. So I'll just check it this. Okay, so these are the all movies I am showing, and if you're going to use shape, the total movies are 437, okay, which are having users rating more than 50. Okay, and in this way we can just have a recommendation, and this data we can save, we can use that further in any of the projects. Now welcome to the second part of this video. So we are going to make use of now content based filtering mechanism here. Content based filtering is a recommender system which are active information filtering system that are personalized in the information coming to user based on its interest, relevance, or the informations, and they are used for almost everywhere. Like we have seen movies recommendation, article, restaurant, places to visit, items to buy, and many more. Okay, you can make use of it. Now the content based recommendation system works with the data that the user provides, either explicitly rating or implicitly clicking on the link. Based on that data, the user profile is generated, which is then used to make suggestions to the user. As the user provide more inputs or take the actions on those recommendations, the engine becomes more and more accurate. The recommender system has to decide between two methods for the information delivery when providing the user with the recommendations. Now, which are two methods are there? Exploitation. So, exploitation, the system chooses document similar to those for which the user has already expressed the preference. And the second one is exploration. The system chooses the document where the user profile does not provide evidence to predict the user's reaction. Now, so let's see how exactly the content which is present inside, we are analyzing that contents, and where the similarity of the contents are mostly possible, that I'm going to use. So here I'm going to make use of one algorithm called as the cosine similarity algorithm, similarity formula, and based on that we are going to make similarity with the data and then find it. So let's go for practical implementation of content based filtering. Follow the link below for a data set of 500 entries of different items like shoes, shirts, along with the item ID and textual description of the item. So what they are given, they given item ID, name of the items, and the textual description of this particular items are present within it. So let's go for that data set here. So the data set is this sample data.csv. I'll open this file and let's analyze first this file, and then we'll go for checking it. So see this one. Okay, for example, so this one first, active classic boxes. This is the item, this is item ID, this is active classic boxes. There is a reason why our boxes are called favorite. They keep their cool, especially in the sticky situation, the quick drying, like many more things are mentioned in that. Or if you go for this, okay, GI toy shorts, base camp favorites, GI t-shirt for the right weights, motion friendly. The description, complete description mentioned. You can see them, insulator pants, steelhead, salmon, like. Okay, so this description is maintained inside it. Okay, and based on this similarity of description, we are going to recommend these particular clothings to others. Okay, so let's check it. So this is what we are going to make use of it in content based filtering. Okay, so we have seen the data set. So data set is in the textual format. So I need to do text analytics or natural language processing to convert that data into the numerical matrix format, and then onwards we are going to make use of this particular data. Okay, so the data set which I have got over here. So before actually going to perform the operations, let's have some theoretical introduction to the natural language processing's vectorizer methods here. Now, what is TF IDF vectorizer? So TF into IDF algorithm is used to weigh a keyword in any document and assign the importance to that keyword based on the number of times it appears in the document. Based on the number of times it appears in the document. Put simply, the high TF IDF score, the rarer and more important the item, and vice versa. Okay, the rarer and more important the item is. So the TF IDF score decides the importance of this particular item in the particular data. Each word or term has its respective TF and IDF score. The product of TF and IDF scores of a term is called TF IDF weight of that particular term. Okay, that's what the TF IDF score means. Now, TF means term frequency of the word. That's the number of times it appears in the document. When you know it, you are able to see if you are using the term too often or too infrequently. Okay, that's what term frequency will define. So TF of T, the TF of term frequency of a particular word. So number of times the term T appears in a document divided by total number of terms in the document. That is what the TF means, term frequency is. And IDF is inverse document frequency of a word, that is measure of how significant that term is in the whole corpus. Now, it's calculated by using log E of total number of documents divided by number of documents in the term T in it. Okay, that's what logarithmic E logs is identified, and IDF, that is your inverse document frequency, is identified. So when we are going to analyze your data, and we'll be making use of TF IDF vectorizer, by which the importance of the data or the numerical conversion of this data is possible by it. So this is the formula that TF IDF vectorizer uses. Okay, so W of xy, that is TF IDF, and you just can see the formula. TF, that is term frequency of x in y, and DF is the number of documents containing x, and the n total number of documents that we are going to have. So this formula is used in TF IDF vectorizer, and based on that we are going to have the value of W over here. Okay, in Python, how it is done? In Python, scikit-learn provides you a pre-built-in TF IDF vectorizer that calculates the TF IDF score for each document description word by word. See this is a pseudo code I just calculated. TF is equal to, this is the class TF IDF vectorizer. Okay, I am using word analyzer over here. Okay, and most important thing is, so when you create this particular objects, I am using stopwords of English and gram range 1 to 3, minimum data frame size 0. So that's what we are going to have. So fit transform, then based on description. What is description? Data set description column is there, that I am going to vectorize. Okay, so this is a matrix containing each word and its TF IDF score with regard to each document or item in this particular case. Also, we are going to remove the stopwords. So stopwords are simply words that are no significant value in our system, like is and the, and hence ignored by the particular system. That's why stopwords I have mentioned over here. Okay, in this way this TF IDF score is calculated and importance of the particular words into the document is identified. So there is one more model called a vector space model, which is used over here in it. In this model, each item is stored as a vector of its attributes. Okay, which are also vectors in an n-dimensional space, and the angles between the vectors are calculated to determine the similarity between the vectors. Okay, similarity between the vectors. So for example, document 1 and document 2. So I want to find similarity between these vectors. So to do this, we are going to create this vector space model, which will, okay, this query will find the cosine theta, cosine similarity values between doc 1 and doc 2. Okay, that's what. So method of calculating users like or dislikes measure is calculated by taking the cosine of the angle between the user's profile vector and the document vector, or in our case, the angle between two documents vector. The ultimate reason behind using cosine is that the value of cosine will increase as the angle between the vector decreases, which signifies more similarity. The vectors are length normalized, after which they become vector of length 1. That's it. So this is how cosine similarity is calculated between two documents. So for example, okay, the two things are there. I am having a tiger and panda. So when I put the tiger, so tiger will be like in two-dimensional plane based on the property will be here, and the panda is here. So if I want to find the cosine similarity between these two items, item A and item B, and theta is the angle between these two. So by using this formula, the similarity, cosine similarity is identified. Okay, similarity between A and B is equal to cos of theta, cos of angle equal to A into B divided by, okay, AB in this way. Okay, that's how cosine similarity is calculated. So we are going to use that particular feature into the algorithm also. So make sure that this is what cosine similarity is identified, calculated, and cosine similarity measures are used here in content based filtering to find the similar items or recommend the similar items in future. So let's check and let's go for this. So first of all, import pandas, and in feature extraction text I am having tf-idf vectorizer class. Then there is a method linear kernel. So with the help of linear kernel I am finding the cosine similarity functions there. Okay, so that's right. Now read the data set and check the data set here. So I'm using read csv sample data.csv. So I've read and check these values are present over here. Fine. So this is how the ID of the particular item and description of this item is present over here. Fine. And now I'm going to create the tf-idf score of the particular data description. So that's what I've done here. tf-idf vectorizer class object is created, and the same things which I mentioned there. Once this is done, I'm going to use fit transform method, by which we are going to convert this descriptive data, description data, into the numerical format data, and then we are going to make use of this. Just a minute, what's the problem here? df, I will see df here. So yeah, df. Okay, so let's check this. So when the object is created, we are going to transform this, and then a matrix of these values is created. This is tf-idf matrix. So if you are going to check the values of tf-idf matrix, okay, see this, so very large matrix is generated. Okay, very large matrix, that's why it's not possible to show it here. How much is that? 500 by 5262 sparse matrix that's generated. Okay, so that's what a very huge matrix of tf-idf score, because data is very high, and the importance of the words, their tf score, idf score, and final addition, final collaboration of the score is also calculated within it. Okay, and then to find the cosine similarity, I am going to have the linear kernel functions. So this matrix we are providing the parameter over here, linear kernel, and then cosine similarities are calculated. So with help of this cosine similarity, our recommendation system will work. Now what I have done over here, so a simple recommendation. So I'll recommend the data, I'll recommend the item based on the IDs. So I don't know the names of it. Okay, what names that they carry, I'll recommend based on IDs. For example, if I'm using this ID number 2, so what are the other data or other items I'll recommend to them. So to do this one, I'm going to make use of it. So cosine similarity is identified. Now first of all, I'm going to make use of this cosine similarity to convert them into the row similar items over there. So what to do this one, how to do this one? So first of all, I'm creating a dictionary here, and from this ds here in ds, sorry, it's df, that is your data frame, I will use iterate this particular rows where the id will be present over here and the row will be present in this particular row item. So two values I am calculating from there. Then here from this cosine similarities I will be sorting these elements by using arc sorts, okay, so that the most similar items will come together, okay, to near items of that. Then similar indices, then similarity we are going to make use of similar items also. So similar items I will be calculating by this method, cosine similarities of I and ds of id of I for every item in the similar indices. This is calculated and that similar items will be storing into the results row id format, okay. So this is how it is done. Just a minute, again one ds yes, okay, that is calculated. Okay, so similar indices, similar items are calculated and then they are stored into the results format. Now finally what we are going to do, so two functions I have created over here. First function is item, okay, so item means the name of the item will be there. See, you just can check it out here. This description completely carries everything, name of the item and the description also, but you just can check it out. Before dash item name is present, so I need to extract. If I want to extract this item name from there, I need to focus on this, which is the name given before dash is the name of the item. So I am going to make use of this item function where which we can find it. So for example, if I am given the id there, okay, if the id is provided, what item name is present at that id, for example id number 4. So this is alpine guide pants, okay. How to find it? So go to that id, okay, check its description, convert to list, split it by dash and its 0th items I am calculating, correct? Are you getting it? Again check it, its location where the id is present, that id and this id is matching, okay. So this id which I am giving and this id, if they are matching, for example it's matching over here, their description I am calculating, converting that description into list format, correct, to list format, okay. Then its 0th item I am splitting by dash, okay, and when you are splitting means converting into the list of words format, okay, but splitted by dash. So before dash is a 0th item present over here. So 0th item is alpine guide pants, which I am extracting and that's returning from this item name. So I am just extracting the item names. I'll show where I'll be using that one, okay. And now recommender systems. Now this is recommend is the function created to recommend the data. So for example, if currently I am using this id, okay, and I want this number of recommendations out of it, that is num. So id for example 4 and item similar to 4, I want to find n number of items, 5 number of items similar to that. So I will be showing recommending this number of items product similar to this item, okay. So item id which is provided, whose name will be extracted here and that will be printed by using these particular functions, okay, the description and then list and then splitting and then item name I am having, okay. Now the cosine similarity function which I am using over here, similar items are calculated, from there I am extracting it. Recommendations equal to results of item id, okay, for example I am given 4, okay, that's, and top 5 recommendations or top 4 whatever I given, that recommendations are identified and then they are stored into RECS function, RECS variable, and from that RECS variable, for example if I given 5 recommendations I want, so this will be iterated for 5 number of times, okay. First recommendation recommended this item and score is this, then next recommend, then next recommend, then next recommend, in this way. See, that's done, okay. So let's check this out. So what I will do, I will use first 15 items here, see, okay. So this first 50 items are present and their names we can see, and I'll just extract one of the IDs and then I'll show how recommendation system is giving this values here. So here I'm using recommend functions. Now if I'm using current ID is number 12, so let's go for 12 number. Baggies shorts, okay. So this is baggies shorts here. So from baggies shorts, what are the different items which are similar to it based on the content, okay. How many items you want? 5. So this value will go here, this value will go here, In num, this value is id, this value is number of items. So recommending 5 items similar to items number 12. So item number 12 is extracted from here. Its name is baggies shorts. Okay, that we are going to find, and from this similarity measures results which I calculated, we are going to have these item IDs, this number of items extracted and stored in RECS, and from that one by one I am printing. Just a minute, what's the DS? Okay, in the problem of DS is there. Just a minute, this is DF. Okay, now see, this is how the recommendation system is now working with, and we have recommended, yes, check out the recommendations. Now how many recommendations are there? Product similar to baggies shorts, recommending 5 products similar to baggies shorts. So I got river shorts, their score is 24%. Then babies baggies short is 16%, baggies shorts 16, girls baggies shorts 14, baggies shorts again it is 14. In this way they are created with the cosine similarity scores, and this cosine similarity scores, as they are calculated, they are extracted in the descending order, and then we can see the product similar to that particular item. So you just change this one. For example, item number 10. Item number 10 is baby sun bucket hat. So its similar item is stream brim hat. See, first item. Then baby's baggies shorts. Then girls baggies shorts. Baggies shorts, like, check it out. Go for item number 6. Item number 6 is ascensionist jacket. Okay, so guide jacket, similar items, you can check, they are extracted, and then they are shown top 5 items of same kind. So this is the way how we are going to make use of the content based filtering mechanism, filtering algorithm, to extract the data, find the similarity among this data, and this cosine similarity function will be applied, and then we will find the item which are similar to the previous items based on their contents. This is okay. So this is how the content based filtering algorithm actually behaves. So this is how we are going to do the recommendation systems here. Just try this. The program is given to you along with it. So what are the advantages of these systems? First advantage is user independence. Collaborative filtering needs the user's ratings to find similarities between the users and then suggestions. Instead, the content based method only has to analyze the items in singular user's profile for the recommendations, which makes the process less cumbersome. Content based filtering would thus produce more reliable results with fewer users in the systems. Second advantage is transparency. Collaborative filtering gives recommendation based on other unknown users who have the same taste as the given users. But with the content based filtering, items are recommended on feature level basis. So this is what difference that they are having, maybe advantages and maybe disadvantages. So no cold start. As opposed to collaborative filtering, new items can be suggested before being rated by substantial number of users. And what are the disadvantages of it? Limited content analysis. If the content doesn't contain enough information to discriminate the item precisely, the recommendation itself risks being imprecise. Remember this. And second is over specialization. The content based filtering provides a limited degree of novelty, since it has to match up the features of user's profile with the available items. In case of item based filtering, only item profiles are created and users are suggested items similar to what they rate or search for instead of their past history. A perfect content based filtering system may suggest nothing unexpected or surprising. These are the disadvantages of the content based filtering mechanism there. This is how the recommendation system, the recommender system, actually works in practical on the actual data set that we are going to make use of this. This is how the program is given also along with this particular video. We just try that, we just perform the operation. If any doubts, the contact information is there in front of you on your screen. Thank you. Thanks a lot.